Okay, hello everyone. So today's presentation will be about Layer2s. So probably, like, how many of you have heard about Layer2? Can you raise your hand? So probably most of the room. Okay, cool. So basically, we are all hearing this term Layer2s, and today me and Michał will try to make it more familiar to you. We'll try to explain the problem, like why the Layer2s were created. Later, we'll show you the current solution, the variety of solutions, and also our own take on the current Layer2s. And at the beginning, I want to say that it is from it will all be explained from the Ethereum perspective, so it could be a bit subjective. And there's like any, I don't know, hardcore fan of other blockchain, please don't kill me. But it will be Layer2s from the Ethereum perspective. So let's go. The first slide is blockchain trilemma. Probably you have seen this graphics many times. People in Ethereum, in Bitcoin, and everyone in blockchain are crazy about it, that they want to solve the blockchain trilemma. So basically the idea is that you cannot have those three in the public blockchain. You have to choose whether you want to be a decentralized, secure, scalable, but it is hard to have all of them. And currently, Ethereum is decentralized and secure, so that is the idea. Okay, so it's decentralized, everyone can participate. So, like, the node has to be slow, the Ethereum needs to be slow, excuse me. So the node can run on a PC, it can be like distributed geographically, and the blocks are not that big, so you can fast propagate the transactions between nodes. Also, it is secure in terms of economic viability. So every node is compensated for the computation. There is a mechanism which prevents the spam attacks and which prevents developers from creating the infinite loops. Okay, and my main idea is that it is not scalable, right? Ethereum has chosen the path to be secure and decentralized, but it is not scalable. So those two, like low throughput and expensive, which it was, let's say, advantage of being secure. So if we have expensive, so the transactions has to be paid in gas, it provides security, but at the same time it does not allow the scalability. And the same goes with low throughput. If you have low throughput, you can decentralize the network, you can have many nodes participating, but at the same time you have the low throughput. So what does low throughput mean? Like, we have only 12 transactions per second. So if every human on our planet would like to make an Ethereum transaction, it would take us over 20 years to do it. So basically, using Ethereum on a daily basis is hard. Also, it can be quite expensive. Imagine the situation when you want to buy something in the shop and currently the memcoin mania has started and you have to pay for the transaction more than the transaction has value in it. So probably it's not the most viable solution for everyday usage. So the first hard to swallow pill is Ethereum cannot be widely adopted as it is right now. Okay, and if we all swallow this first hard pill, maybe there's an idea and solution. Let's just build another blockchain, right? Because Ethereum, it does not scale. Maybe we can come up with something better. And I want to say that some next slides will be a bit spicy, so don't kill me on this one. But the first problem is that if you want to create another public blockchain, it could be fairly centralized, as in case of the Polygon, which is like the Ethereum alternative, which is not that decentralized. You can create a blockchain that has way more transactions per second and it's way cheaper, but it requires you to have high-end hardware to run it, and sometimes loses consensus. Also, there is like, maybe you don't cite me on this one, but also it's a very, very, very big problem that, for example, when you have Ethereum and you have Bitcoin right now, it is hard to start another network because like there is enough computer power in Bitcoin to just overtake your newly created network, or enough value in other networks to just outvote majority of your network. So yeah, another hard to swallow pill is Ethereum is here to stay, and we'll probably need to use it. Okay, so let's just use Ethereum. It has low throughput, but it's decentralized. It is expensive, but secure. So let's make Ethereum great again. And how can we do it? We can add scalability to it, right? We want to add it, but how can we do it? How? Yeah, we cannot solve blockchain trilemma. It's really hard to swallow pill for me, but I promise you that's the last hard swallow pill today. So let's just build another blockchain. But this time let's connect it with Ethereum. And that is basically the idea of Layer 2. So Layer 2, you can think about it as another blockchain, but it is somehow connected with Layer 1. It is a very high-level overview, but basically this interaction is that Layer 2 for sure, like Layer 2 for sure needs Layer 1 to, like, I don't know, check out the state, but at the same time, Layer 1 also needs Layer 2 to scale. And like, there were some early ideas for it. Let's say the very first was the Lightning Network on Bitcoin, and also there was a company called Raiden that they wanted to try to implement it in Ethereum. Also, there were some ideas to scale Ethereum with Plasma, but unfortunately, probably you have not even heard about it, so it didn't pan out well. But then there was the idea about, which Michał will tell you more about right now, that hopefully will get you into it.
Okay, can I have this, please? So yeah, as Antek mentioned, the early ideas, they didn't really work out that well, but then a roll-up-centric Ethereum roadmap. This is Vitalik's post on Ethereum Magicians that basically announced that the current status quo of scaling Ethereum, which is done by rollups. And the important thing here is that Ethereum is not building one official rollup, just like it's not building one official node implementation. It's a free market, so everyone can build their own rollup. If you want, you can build your own rollup, but it's quite complicated. So what is a rollup, okay? So here is a quote that I quite like. And rollups are blockchains that post their blocks on another blockchain and inherit the consensus and data availability of that blockchain. This doesn't have to be true for all the rollups implementation, but it is kind of true for all the rollup implementation that exists right now. So you can see those are two different blockchains. There is a rollup chain and L1, which is Ethereum in our case. And basically we take the data, the rollup chain, and compress it and put it on L1, okay? So thanks to that, we don't have to do all the computation on layer 1 and use all the computational power of each node to verify it, right? We can just use some kind of smart way of actually leveraging this, this way. I will talk about this, about the state validation in a second, but basically we are allowed to compress the data that's happened and all the things that are happening on the rollup chain and put it on L1. So rollup, they post their blocks on another blockchain, and this is Ethereum in our case, and they inherit the consensus and the data availability from that blockchain. And this is really important because we can have a blockchain that is completely permissioned, but because it is a rollup and it operates as a rollup, it basically inherits the security from Ethereum. Most of them, they have a special contract on the L1 that maintains the state root, and those are the smart contract rollups that we will focus on today. And they should be trustless, permissionless, and censorship resistant. We'll speak about it. It's not the case every time. Okay, so we showed how the rollup can look like, and now we will speak about the specific roles on the blockchain. This will be important in the other part of the presentation. Okay, so if you heard about rollups, who here heard about sequencer? Okay, so basically, as I showed you before, the rollup is this chain, and this data is posted on L1. But there has to be somebody who posts this data on L1. And in the perfect world, that could be anyone that posts the block data on L1. Unfortunately, because those rollups are very hard to write system, it's way easier to just have, okay, so we have this guy in a hat who is a sequencer, and this is a central actor who is allowed to, so this is a central actor who is allowed to go into interaction with the L1 contract and post the data, all the transactions put in the sequence. So if you are a user, an Alice or a Bob, and you want to send a transaction on a rollup, what you have to do is you have to send your transaction to a sequencer who then who puts them in order and then posts this on L1, okay? Just remember about that because it will be important in the next part. So here you can see that it doesn't happen on its own. It's a sequencer that posts this state on L1, these blocks on L1. Okay, now the next role is a validator. And the validator is a person who actually validates the state. So sequencer, he just makes the data available on L1, whereas the validator, he will say that this state is actually the true state of the rollup. And it will normally include the hash of the state hash on a current block, and will basically allow people on L1 to withdraw money from rollup, for example. So here you can see that, yeah, there is a sequencer who posts the data, there is this validator who updates the state, and also we have this state validation mechanism that I mentioned already. We have the optimistic rollups and pessimistic rollups. No, I'm just kidding. It's optimistic and zero knowledge rollups that we are having right now in the space, okay? So optimistic rollups, they require fraud proofs to validate their state, but zero knowledge rollups, they have zero knowledge validity proof, okay? So here you can see how a fraud proof looks like. So basically, you can think of, so when somebody, when validator validates the state on L1, he basically says, here, does the state trust me, okay? And it opens something that we call the dispute window, which is normally 7 days. And this is the time window when other actors can basically challenge them, and they go together to court, and who wins and gets the stake, and the other actor gets slashed. So basically, it's kind of game theory idea that allows us to validate the state of a rollup. The other way that we can the other way in zero knowledge, this is through a true image of a mathematician creating a zero knowledge proof. So basically, I mean, it's obviously a joke. It's not how it looks like, but it's a really complex mathematics that allows us to prove something without revealing any information about that. Adam here was speaking about zero knowledge proofs in terms of privacy, but they are used in a little bit different manner with rollups. So basically what they allow us is creating a zero-knowledge proof is quite expensive by a prover, okay? Those are normally very big contracts, very big machines on AWS or something, but actually verifying the proof is really easy and inexpensive. So this can be done on L1, and this is like a compression of this data that we can get from while using this technology. Yeah, so this is a reminder how it looks like, and so basically we have this sequencer validator that validates either in an optimistic way or zero knowledge way, and here you can see that the good thing about optimistic state validation is that it is quite simple. Let's say, like the idea is it's not really hard to think of, although you have to basically create EVM inside of EVM for the fraud proofs, but yeah, that's another thing. And the thing about optimistic rollups in that if everything goes good, you basically just post the data on L1. You don't have to do any extra work. If everyone is honest, then this is actually a very efficient system. The con is you have to wait. I said 7 days, but it can be any dispute window that the system is using. Pros of zero knowledge rollups is they're kind of fast. It's few hours finality. Basically, when the batch is ready, the batch of transactions is ready, it's posted on L1 and verified immediately. But the cons, and it's really big con, is very complex. And basically we are not really sure, and we cannot really be sure until like maybe few years in the future that the current systems are really working well and they have no bugs, right? Okay, so basically, as you can see, this is not simple to understand. And what we do in L2BEAT is we try to quantify, and we are a research and analytics about layer 2 systems, and we put some numbers, so like TVL or whatever. So it's you can see which one is first or second. That's really interesting. But what we are very proud of is the risk analysis framework that we post on our website. And basically here, you will know now why I spoke about what's validator and what's sequencer, because this is a framework that we try to talk to people about L2s. The thing is that the rollups, their data should be available. The state validation system should be deployed. I'm looking at you, Optimism. And they should be trustless. They should be safe. They should be good for the users to they should be basically safe, right? But the elephant in the room is the upgradability. So as you know, the smart contracts on Ethereum are immutable, but it doesn't mean that they are not upgradable. And upgradability is a really hard thing to speak about, don't you think? Because we would like to have non-upgradable systems. That sounds really nice, and actually there is a rollup right now which is not upgradable, but I think that's a bold move, especially with such an complex system, and that's the problem. It's really complex. The rollups are one of the most complex systems, complex rollups, complex smart contract systems deployed on Ethereum. And basically upgradability allows them to function right now and try new ideas. And so something that we are thinking about talking about more is a security council, and basically it's a special multisig that's selected out of public figures that that it's the only actor that's allowed to push for a change in case of security upgrade. Okay, so right now, some of those systems can be upgraded by a single EOA and basically steal all your funds. Security Council would be a good idea. Next thing is data availability. So basically, we have two ways to deploy a rollup. It can be in a rollup mode or in Validium mode. Validium mode, it's not posting all the data on chain. It's posting the data to the data availability committee. So when you ask them nicely, they can provide to you this data. And this is a simple, it's a simple image showing comparison between rollup and Validium. And yeah, the last thing I want to talk about is censorship resistant. And because there is few ways to make sure that your rollup is censorship can resist censorship. Okay, we have those two central actors, which is a sequencer and validator. And so the first thing that's possible is forced transaction. So as I showed you before, the sequencer is the actor that's allowed to pose a transaction on L1. But it can happen that the sequencer doesn't like Alice, right? Alice is not a friend of sequencer, or maybe they have, I don't know, they have different political views. Maybe they are economically incentivized not to get the transaction from Alice. So there exists a way that you can implement in your layer 1 smart contracts to force the transaction on L2. So basically, Alice can call a special function on L1 contract that then forces the sequencer to include this transaction in the next batch. Okay, and the last thing I wanted to spoke about is the liveness problem. And basically, the rollups are working right now, okay? You can put your money into Arbitrum, you can put your money into Optimism, you can put your money to any of StarkX implementations. And what's important to think about is that what happens if the operators, that the sequencer or the validator, they stop answering our calls, is we can, there exists a way to create an escape hatch. An escape hatch is basically a special functionality built into the L1 contract that allows a user to prove that they are the owner of some asset on L2 and can withdraw the money from the escrow. Any questions? Okay, I guess that was a little bit too technical. Yeah. So basically, a Polygon proof of stake, there is a bridge that, so it's a side chain from Ethereum, right? So the important definition of a rollup is that it inherits the security from Ethereum, and Polygon is not one of the systems like this. In our definition of layer 2, we don't consider it to be a layer 2. That's a good question. I cannot answer you that question, sorry. I'm not sure about Polygon. Do you know, Ante?
Yeah, like I made this slide, but I'm not also very into Polygon. But what I can say to you is that you can visit our FAQ page, and there is like everything described. Because to be honest, like the question about Polygon is the question we get most of the time, and it is well described in FAQ. Yes, yes. Yes. Yes, yes. Mhm. Yeah, and I would say that we at L2BEAT, we just try to put some light because currently, if not for L2BEAT, there will be just people claiming that Layer2s are the way to solve Ethereum because Vitalik has told it. But currently, it is all one big beta. And to be honest, we just try to make our own definition of what Layer2 is and what is not. Polygon is a really tricky one, okay, but to be honest, I would say it's just one big experiment at the moment. A lot of money locked in, a very big bug bounty. But as you said, there is so much darkness. For example, if you just look in this column, like sequencer failure, right? Some are black, but at the same time, you just want to use layer 2, but at the same time, you are just using the sequencer, like only one entity who posts the state. So basically, all the layer 2 is just one big beta. And I would say to you that I agree. There is a lot of place for progress, but what you can do, thanks to us, is that you can see that most of the systems are not yet ready. But anyway, people are using it, so. Mm-hmm. 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 Yes, yes, I know what you are talking about. Because you have to put in advance the gas limit and stuff. So if the economical situation changes, your transaction will not pass on L1. But I'm not sure whether they have not like advanced. Mm-hmm. Yes, I think in case of Optimist, there's just no gas limit. That's how they mitigate it. And in Arbitrum, yeah, I I know what you are talking about. We can talk about it later, maybe a bit more. Yeah, but fully agree that current state of layer 2 is just one dark forest, and we just try to unveil it a bit, but you know. Yeah, but we are just making presentation about layer 2s, about L2BEAT, but it's not like we are not encouraging anyone to use it. We just say it enjoy responsibly. So you visit our website and see what are the risks. But I fully agree that we should definitely tackle the problem that you told. Thanks.